Okay, this is section 8, examples of Heron's formula. Okay, in the last video, I have mentioned to you about the Heron's formula, which is the area of triangle is square root of s times s minus a times s minus b times s minus c, where a, b, c are the sides of the triangle and s is half of the perimeter of the triangle. That means 1 over 2 bracket a plus b plus c. So by using this formula, we can only use s, all the sides, then we can find the area of the triangle. Here are some examples for you. The first example is there is a right angle triangle ABC. We want to find the area. So every primary school students can find its area very easy because these two sides are perpendicular to each other. That means one is the base and one is the height. Therefore, we just time them up and divide by 2. It will give us the answer. So the answer is very easy, which is the base times the height over 2, which is 6 units. In this example, we still can use the Heron's formula to show you the formula is correct. So in this case, there is only 2 sides. We can find the other side, the hypotenuse. So by Heron's formula, we can first find AC, the hypotenuse, which is square root of AB squared plus BC squared, Pythagoras theorem. So which is 3 squared plus 4 squared, and take the square root. The answer is positive 5. So up to now, we know all the sides. So we can find S, which is half of the perimeter. So which is 3 plus 4 plus 5 over 2, which is 6. Therefore, the area of triangle ABC by Heron's formula, which is square root of 6 times 6 minus the first side, 6 minus the second side, and 6 minus the first side, and multiply them up. So the answer is square root of 36, which is 6, which is the same as the previous method we used. So example 2, we see an obtuse angle triangle. And obviously this is the height of the triangle, AH is the height. We want to find the height H and correct the answer to 3 surrounding figures. So in this case, you are given 3 sides, so we can use the Heron's formula to find this area. On the other hand, we can use the height and base to find the area of this triangle. So first of all, if we want to use the Heron's formula, we have to find S, which is half of the parameter. Therefore, we can use this to calculate the answer. The answer is 23 cm. Therefore, by using the Heron's formula or by using the traditional method to find the area, they are still the same. So from the left hand side, it is the Heron's formula method, and this one is the traditional way. So we can construct this equation and find H. The answer is 14.8 cm, correct to 3 surrounding figures. Okay, we go to the third example. You are given a triangle PQR. The sides are given but with unknowns, which is 4x, 5x, and 6x. Obviously, x is positive. If the perimeter of this triangle is 45 cm, that means the sum of all the sides are 45 cm. Find A, the value of x, B, the area of this triangle. So you are given the perimeter. Can we find the value of x? It is very easy. Therefore, the perimeter 45 is just equal to the sum of all the sides. So we can find x equal to 3 very easily. Once we have the value of x, we know all the length of the sides. So if we know all the lengths of the side, we can find the area very easy by using Heron's formula. So always before using the Heron's formula, we always need to let S as the half of the parameter and calculate it. So in this case, we don't have to calculate it again because you are given the parameter is 45. So half of the parameter is just S, so you don't have to calculate. You need to calculate this. The area is just square root of this. And you need to substitute x back, of course. So the answer is xt 9.3 cm square. We go to the final example. Example 4, you are given a quadrilateral PQRS with two sides are given and include angle is right angle. Also, you are given these three sides are the same, which is PQ, QR, and RS. So they are all 12 cm. So all the sides are given. Find the area of this quadrilateral correct to three significant figures. So in this case, this quadrilateral is formed by two triangles. The first one is a right angle triangle. The other one is an isosceles triangle. So in order to find the area of this, you can find the area of the upper one plus the lower one. So the upper one, for the right angle triangle, you just need to multiply them up because one must be the base, one must be the height, and over 2. Then it can be formed very easy. It can be solved very easily. For this one, you need to use Heron's formula, for example. Actually, there are many methods, but in this section, we have learned the Heron's formula, so we need to use the Heron's formula. So this side is known, this side is known, and this side can be calculated because this is a right angle triangle. So this is the hypotenuse. That means we can use the Pythagoras theorem because it is a right angle triangle. So you can just calculate this to find the side, and the side PR is 15 cm. So now you know this side, that means triangle PQR, all the sides are known, and this triangle, the area is very easy to find. So again, we need to use Heron's formula. We need to first find the value of S first. For triangle PQR, S half of parameter is just the sum of all the sides over 2, which is 39 over 2 cm. Therefore, the area of the quadrilateral PQRS is first the area of the right angle triangle, 9 times 12 over 2. The other one by Heron's formula. This one, because they are the same side, so I use square because the same number multiplied together is the square of the number. Finally, we can find the answer, which is 124 cm square, correct to three significant figures. So you have learned all these 4 examples. Please do homework 3 about the Heron's formula. Please finish all these questions and hand in to teachers when you come back to school. Thank you.